Hi, so welcome to another class, and for today's lecture for this week, will just be a continuation of your Newton's law of motion. So before that, after that, it's really important for us to go back to the basics. Okay, so to start is science is of course the knowledge based on observed facts and tested truths. Okay, so whether they're tested and found out to be true in an orderly manner, then it is how we do science. Okay, and scientists are the people who are practicing this this um, this kind of I don't know what they call it, but they practice this. Okay, so it came from the Latin word scientia, meaning knowledge. So physics, on the other hand, is a science devoted to the study of matter and energy. So physics is on the matter and energy. So it is considered one of the most useful fundamental sciences. So there are actually two major branches of physics. So we have classical physics and modern physics. So science is a creative process. So here we started with observation. Okay, so observation starts with studying an object or noting. So this requires imagination. So um, so the reason why many people are saying science is to see is to believe. Well, actually, it's actually a fundamentally flawed philosophy, because not everything that we can see, not everything that we see doesn't exist. Okay, so for example, gases, they're quite small, and for example, viruses and bacteria, so they're quite small, but you can't say really that since you can't see them, they doesn't exist. Okay, so you have to change your perspective on that thing. So science is a creative process. So again, we started with observation, then followed the formulation of theory and testing theory. So for example, we observed that the birds are flying. All right. So that's what our observation is. So the birds are flying. So the formulation of theory is, so you're thinking, um, will birds still fly in a vacuum? So those kinds of questions might be silly, but not really exactly birds, because birds have wings. You know. So your real question is, do wings still work in a vacuum? All right. So that's a very good. So for example, observation is that animals can fly, but not all animals can fly. And at the same time, everything that has wings can fly. So that's your observation. And your formulation of theory and testing of theory is like this. So will will wings still work in a vacuum? So that's your theory, and that's your question. And you're going to test your theory. So how are you going to do that? So um, you're going to make hindi naman yung ilalagay mo yung bird dun sa vacuum kasi mamamatay yung bird. So all you need to do is to replicate replicate wings, and then test it inside a vacuum. So that's it. So it says here that theories are never actually derived directly from observation, because like I told you, um, you can I mean, we can only use observation as a guide or as a inspiration to make our theories, but the theories cannot directly derive from observation, which is true. So so this is a result of a human imagination. For example, you imagine something, and this is the result of your imagination, a theory. Okay, so development of a physical theory is always a two-way process that starts and ends with observations and experiments. So, I don't know, hindi naman tayo laging ganito, no? So, when we ask something, when we have a question, we don't always end up doing experiments really. Hindi naman ganun. For example, bakit ang mahal-mahal ng presyo ng bilihin? So, gagawa experiment. So, no. So, Theory is ever regarded as the ultimate truth, where there is always a possibility that new observations will require revisions of the theory. Well, this is true. For example, even laws. Okay, so theories can be changed. Theories can be validated, whether they are true or not. At the same time, laws. Okay, laws can also be disproved or proved. So, take for example, one law that is accepted before is the law of universal gravitation. Okay, so let me check on Google. Law of universal gravitation. Okay, so the law of universal gravitation by Isaac Newton before was accepted, but it was found out to be not true. Okay. So it says here that everything that has a mass has a force exerted. So this is not actually true. So they already disproved this one. So the only remaining true as of today is the theory of Einstein, which is a theory of relativity. Okay. But we don't have to discuss this one yet. So we can never prove a theory. We can never prove that a theory is always correct. So it's not always correct because a theory can also be false. Okay. So science is a creative process. So since it's a creative process, you have to be open to other theories. Right? So for example, Copernicus said that all planets revolve around the sun, but Ptolemy said that the sun revolves around the earth, which is we already know that the sun does not revolve around the earth, but this is because this is already proven. But earliest debate, the reason why Galileo was imprisoned is because he made a very significant objections about the Catholic Church believing on the theory of Ptolemy, which is the sun revolves around the earth, which is blatantly false. Right? So, mabagal ang internet ko, na lang. So, we use models, theories, and laws, okay, to explain observations or things. For example, models, if you remember my discussion in engineering data analysis, models can also be explained using formulas. Okay, so formulas. In engineering, we use mathematical equations to show relationships. Thus, we can have models. Okay, and laws can be explained by models. But theories can also be explained by models. Yeah? So a model is a diagram, a design, an image, scheme, or representation used to explain or describe a concept. So it can either be a formula or an image. So we don't have to talk about that one. So we started with theory here, then we use a theory to make a prediction, experiment, okay, and then we see observation. So what happened? So what happened during the experiment? So theory with more detail and gives quantitative testable predictions with great precision. So theory is a quantitative testable prediction, okay, with great precision. Okay, so again, you might be already wondering what's the difference between accuracy and precision. I already discussed that during the EDA. So dun sa EDA, the difference between precision and accuracy. So here, again, since theory cannot be always true, it means that it doesn't have accuracy. Okay? It can be true or not true. So, precision lang. So, walang accuracy dito. But when we say precision is, when we have a formula, and that formula is based on the description of a theory, we can always rely on the formula to give us a value, particular result. And that's precision. So, a law and principle are both accepted, verified, proven, fundamental scientific relations. So, when you say a law and a principle, they are accepted, verified, and proven fundamentally scientific relations. Okay? Proven and accepted in that sense. But again, laws and principles can always be debunked. Pero matinding debate yun. Maraming kailangang data to prove that the law is not true. Okay, so measurements and uncertainties here. So again, physics is an experimental science. So we have here quantitative. So Nagre-rely tayo sa mga measurements and calculations. So we expect that models are represented in figures and in mathematical equations. So there is a measurement for every experiment. Okay, so we use numbers to describe the result of experiment or any measurement. So here, every measurement has uncertainty. So when we say uncertainty, there is a very little accuracy. Okay, so you might be already, so just a remember or a review of your EDA, measurements are continuous variables. So it means that you can always express a particular measurement in very specific. For example, if you're given 1 kilometer, 1 kilometer can also be expressed in terms of meters. That is, 1 kilometer equals 1,000 meters. Wherein, 1 meter is also equivalent to 1,000 millimeters. And 1 meter can also be expressed in terms of 100 centimeters. So basically, 1 kilometer can also be expressed in terms of millimeters, and that millimeters can also be expressed in terms of nanometers, micrometers, and picometers. So, paliit ang paliit. Okay, so it's very difficult for us to have a measurement. So, when you say that your height is 5 feet and 4 inches, it's not really exactly 5 feet and 4 inches. Because, baka, 5 feet and 4.1 inches. Or, that could be 5 feet and 4. I don't know, 0.111. Or, that's a very, so, not to say that there is always uncertainty or meron tayong limitations sa ating measurements because, meron kasi may measure exactly. So, there is an uncertainty or accuracy for this one. So, when we say 4.2 centimeter plus or minus 0.1 centimeter, itong 0.1 centimeter yung tinatawag nating uncertainty. So, that 4.2 centimeter can be plus 0.1 centimeter or minus 0.1 centimeter. So, anong ibig sabihin nito? Ang ibig sabihin niyan, guys, ano ito? Okay? So, for example, this is your 4.2. So, this is plus 0.1 minus 0.1. So, this is your range for plus 0.1 and plus minus 0.1. So, you are saying that your measurement is true within this range. Okay? So, yan yung value mo talaga, yung totoong value. Okay? So, it could be here, 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 it could be here. As long as you're saying that this is your range. So, anything inside this range is your true accuracy. Okay. Okay, so yun yung true. So, no measurement is exact, which is true. There's always some uncertainty due to limited instrument accuracy and difficulty reading results. So, papansin nyo, di ba, meron tayo mga meter or readings dito. So, minsan kasi papapansin mo, nasa gitna ng dalawang guhit. Di ba? Ang hirap, di ba? So, you're always going to say an uncertainty. But, sir, pwede ba natin, sir, na walang gamitin na ganyan? Well, pwede. Pwede naman. But, we are doing this just to show you guys that there is always uncertainty in terms of measurement. So, we cannot be always exact. Okay, so wag na yan. So, this is significant figures, no? Okay. So, dito naman, if you're going to look at this, 0.2 over 0.3, so 2 divided by 3 is 0.6666, or you can always say 6666. But for this one, 2.5 times 3.2 is an exact number, which is 8. So, calculators will not give you the right number of significant figures. They will always give you too many. So, kasi calculators cannot give you an exact value. So, they will give you as many digits as they can. Siyempre, limited yun sa number of resolutions sa calculator. But to us humans, what's really useful is around 6 decimal places or 4 decimal places. Pero siyempre, may error pa rin yun. But the point is that the higher the decimal places, the higher the accuracy. Okay? So, physics experimental science, kanina nga. So, physical quantity, we have length, which is meter. Okay, so mass, kilogram, time, second, electric current is an ampere. Temperature is Kelvin, amount of substance is mole, luminous intensity is candela. So yeah, I already expecting that you already know how to convert units though. So order magnitude rapid off. So we don't have to talk about those things. So what is? Okay, so going to vectors and scalars for the last week for the last topic of the week one. So scalar quantities are this is just a review of your physics. So scalar quantities are quantity that only has magnitude. So this is a pure number. It can be the positive or negative. So it can be added, subtracted in the usual way. So it may have a unit after it. For example, 1 centimeter. This is a scalar quantity. So vector quantity has both magnitude and the direction. Okay, so sorry for the interruption. So going back, so vector quantity. So this is how we make a notation of a vector quantity. All right. So, okay. So vector quantity. Okay. So for example, this is your vector. A bar. Sir, pwede po bang A lang po ba lagi? Pwede actually B, C. Okay, so papansin niyo, ito lang naman importante dyan eh. As long as you have this direction, so it means this is your scalar quantity, this is your magnitude, this is your direction. Okay, so again, a vector quantity is combined of a magnitude plus direction. So that A is a magnitude and the direction is this one. Sir, pwede po bang ganito? Okay, so let's check later. Wala eh. So you can only have one direction. But the point is, you are just saying that there is a direction. Hindi naman ibig sabihin na papuntang dito lang. Eh, yan lang yung direction. Hindi. Ang gusto na sabihin yan eh, notation lang yan na notation lang yan na ang magnitude na yan ay mayroong direction. So, hindi ibig sabihin na pag ganito yan ay pag ganito. Hindi ganon. So, notation lang yan. Okay, notation lang. Okay, baka hindi nyo alam kung ano notation. Ano ba ibig sabihin ng notation? Diba, wala akong internet. Okay, wala akong internet ngayon. Right, so, this is only to signify or to make a notation that this magnitude has a direction. So, kaya siya nagiging vector. Yun lang naman. Okay? So, balikan natin. So, when you say a magnitude of a vector, okay, again, this is a vector. But when you say a magnitude of a vector, dapat nasa loob siya ng itong bar. Or, diba, when we say that, for example, 2, nasa loob yan, diba, ang sagot natin dyan ay 2? Alright? Kasi, kapag nagkaroon tayo ng negative sign dyan, 2 pa rin ang sagot niyan. Kasi everything that inside this bar ay nagiging positive. Kasi yun yung tatawag na absolute value. Okay. So, a magnitude is an absolute value. So, the graphical representation arrow is the length of the arrow is proportional to the magnitude of the letters, the same as the direction of the vector. So, two vectors are said to be equal if they have equal magnitudes in the same direction. Okay, so remember, the two vectors are said to be equal if they have equal magnitudes and same direction. Okay, so same direction. Oh, makatawag ko dito. So, same direction. Same direction, at that they are equal. Okay, so these are equal. Two vectors are equal in the same direction. So parallel if okay, so parallel if they have same direction, anti-parallel if they have the opposite direction. Anti-parallel if they have an opposite direction. And this can also be wait lang. So, if you have a vector like this, and you have an opposite vector like this, okay, so pinagtatama yan. Okay, so pinagtatama yan para makuha yung resultant. So, it's either papunta dito, or papunta dito. So, sir, sino pa nakadepende? Nakadepende yan sa magnitude nitong, nakadepende yan sa magnitude nito. For example, ito yung A, yung B. Okay? So, kung mas mahaba si B kaysa kay A, malamang mananalo ito. So, ibig sabihin B minus, wait lang, kumaya na lang. Okay, so, vector addition. Okay, so how do we add vectors? But before that one, what is really a vector? No, it's really weird for you to say the vectors. Okay. So, give you the background. For example, dito kasi sa Moodle may maganda akong picture dito ng vectors na para maintindihan mo talaga. Okay. So, drawing ko na lang baka na internet For example, ito yung airplane. Okay. Okay. So, the movement of the airplane is like this. Okay. Paano may hangin? Okay. So, we have an air. So, we have an air that goes like this. Okay. And what else? Alright. So let's say that this is the vector of your airplane. So let's say this is A and this is wind. Okay. So that's gonna be A plus W. So ano yung magiging resultant? R. Okay. So when we say resultant, ano yung magiging final direction ng airplane? So when the airplane is moving like this and you have a wind against you, okay, so isipin nyo na lang, no? The airplane is not moving in a two dimension because the airplane is moving in a 3D direction, in a 3D. Okay? So, ito yung tendency niya papansinin nyo. So, since we have a wind like this, the airplane can move slightly like this, right? Kasi mauusog siya. So, the question is, what will be the direction of the airplane? So, since diretso siya dito, papunta ba dito ng airplane? Malabong naman. Malabong mangyari yun. Ang magiging malinaw na direksyon ng airplane is pag ganito. So, hindi na siya magiging straight line, kundi lilihis siya ng konti kasi may hangin. Pero kapag walang hangin dyan, okay, kung walang hangin dyan, automatic, dire-diretso lang yung airplane. Walang mangyayari. Walang magbabago sa kanyang direksyon. So, ibig sabihin yan, class, ang resultant, yun yung magiging direksyon or tatahaking path ng airplane mo. Kapag kinukonsider mo ng ibang factor, gaya ng direksyon niya at ang hangin at iba pa. Okay? So, yun. So, ganun po yun. Okay, so there are two ways that we can determine the resultant vector of, for example, two vectors. So we can do a tailhead method or a parallelogram method. All right. So let's try to use the simulation here. So go to pet simulation and open vector addition, then play. Okay, so we're going to do the lab. Right. So when we say you have two vectors, okay, for example, this is letter B. Ito kasi may edit yun, yung left trial For example, we have a vector that goes like this. So straight line lang, no? For example, ito yung airplane natin, yung V. And then we have another vector, let's say wind, that is going against you. But let's say the wind is quite strong, no? Okay, so okay, 90 degrees. Okay. Okay. So, if you're going to toggle this, always remember that a vector always has a x component and a y component. Sir, paano nangyari yun, sir, na may X component and Y component? Okay, so ganito yun. So, if you're going to look at this one, you know, the movement of this vector is depends on two things. The one that moves it to the right and the one that moves it to up or down. So, dalawang laging force ang magkasama dyan. If we're going to move something, for example, if we're moving like this, so, ang isa lang nakikita natin, X component lang. Walang Y component. Kasi, we're not dragging the vector going down, unlike this. So, ano ba magandang idea tungkol dyan? For example, if you are printing something, for example, this is how a printer prints. So, for example, magsa-start yung pangalan mo dito, dito, tapos magsa-stop yung printer, dito na naman siya mag-print, dito. So, ganun mag-print, or ganun mag-print ang isang printer. So, gumagamit siya ng Cartesian coordinate system. So, always remember na ang printer is laging merong motor, may motor na umihila papuntang x-axis, at meron siyang motor na nag-umihila papuntang y-axis. So, wala kasi ang net eh. Okay, so hindi ko kasi mag-explain sa inyo kasi wala tayong face-to-face sa class eh. Pero pag na-face-to-face class tayo, papakita ko sa inyo kung paano talaga gumagalaw ang kamay ng printer. So, merong motor na papunta dito, na humihila sa kanya papunta dito, at may motor na humihila papunta dito. So, nagbabalanse yung dalawa para makapunta yung printer o yung needle papunta kung saan siya gustong pumunta. So, always remember na ganun yun. So, there will always be an X and Y component in a 2D. Okay? That's a component. Now, let's say yung wind dito kanina. So, now we're going to do the vector. Right? So, this is the vector. Wait lang. Alright, so let's start off sa scratch. So, ganito pala yun. So, lahat ng blue, yun lang gagamitin natin. For example, this is the wind. And this is the movement of the plane. Okay? So, yung haba, again, so sabi ng book, notes, kapag mahaba yung vector, yun ang magnitude niya. Okay? So, ibig sabihin ng airplane, may ganitong magnitude. So, let's say, medyo malakas ang wind, so ganyan lang. So, we're going to determine the direction of the airplane. Then, alright? So, ibig sabihin, yung airplane natin lilihis. So, yung airplane, pupunta dito. So, kanina, dire-diretso yung airplane, ay biglang humangin na palid. Kaya dumetso dito yung airplane. So, lumihis siya. Okay? So, going back to the lecture, what I'm going to do is a tail head method. Okay? So, dito sa lab, so we have, for example, hindi pa natin alam yan, yung vector resultant. So, vector sum or tail head method is like this. So, you can either, okay, so remember that you're going to attach one tail end to another. So, dito na yung isang end. So, kita yung end. So, yan. So, our resultant is yung missing. Okay? So, yung missing. Yan yung magiging resultant. Now, to find the length of the resultant, all you need to do is to use the distance formula. Pero, ibig sabihin yan, meron bang shortcut way? Yes, sir. Meron pong shortcut way para malaman kung ano yung resultant at ang direction. Meron po. Okay? So, yun yung ituturo ko mamaya dito sa slide. At ganyan po yun. So, this is a tail end method. How about the parallelogram method? Parallelogram method is you're going to join them at both ends side by side. And, voila. Ganyan. Okay? Ganyan lang po yun. So, that's it. So, this is how you're going to determine the resultant. So, this is the direction of the airplane. So, if the wind is going like this. So, at the airplane is going like this. And, yeah. So, ang direction ng airplane na to, mapapalid ang airplane. So, paano pag niliitan natin yung, di ba? Kapag nililiitan natin ng wind force, pag maliit yung wind force, ibig sabihin ay wala na. Parang konti lang yung konti lang yung magiging galaw ng airplane. Lilisan siya ng konti. Pero kapag biglang lumakas yung hangin, di ba? Didiretso dito yung airplane. So, paano nagigets nyo, no? Yun ang naman yun. So, ulit natin. So, paano kapag magiging tatlo na yung vector natin? No? Paano pag tatlo na? For example, ito yung plane ulit. So, straight lang yung plane. Meron tayong hangin andito, hangin na habagat, at meron tayong hangin dito na palusob naman, padiretso. Right? So, for example, ito yung airplane mo, movement ng airplane mo, ito yung air na habagat. Ito naman yung air friction. So, ito yung magiging air friction. So, ano magiging resultant niyan? Okay. Now, to find the resultant of this one, we can either use two of the technique. So, tail end method. Parang hindi maganda. Okay, tail end method tayo. Okay, yan. Tail end method. Tail end method. And then, we're going to do the sum. Okay, so, ta-dan! So, yan ang resultant. So, ibig sabihin, going back, this is the wind, yung habagat, and this is the movement of the plane, straight line lang siya. At then we have an air friction that is against the movement of the airplane. So, ibig sabihin, ang movement ng airplane ay ganito. Kakalabanin yung air friction. Ganun yung direction ng airplane. So, ito yung sense ng vectors, okay? So, sana nagigets yun, no? Ito yung movement. Okay, yan. So, tapos na tayo dyan sa lab. Okay, so, computation tayo. So, going back, so addition, for example, if two vectors are equal and the same direction, you're just going to add them. So, 5 meters of 5 meters, so ganun lang. So, pag parehas ng different direction, so sum nyo lang din. Pero kapag magkalaban sila or against sila, okay, so 0, ka-cancel out. So, dito naman, 10 meters ang pakanan, 5 meters sa kabila. So, syempre, ang mananalo, 10 meters, so 5 meters. So, naman, 5 meters ang pakanan, 10 meters naman ang kaliwa, so negative 5 meters. Kasi nanalo ang 10 meters na negative. Yun lang. So, dito naman, okay, so ito na yung pag-compute. So, during algebraic method, so ito yung pwede na sabihin na tail end method. Okay, so gumagamit siya ng trigonometry kasi nga, mapapansin nyo, mga triangles ito. So, for example, dalawa lang. So, tanggalin natin ito, no? Tadan! So, tail end method coming. Okay, this is the tail end method. Alright. So, if vectors are perpendicular, the magnitude is to solve this in the Pythagorean theorem. So, this is the vector. The resultant, C. Alright, so C is equals to the square root of A squared plus B squared. Now, try natin compute, no? So, this is the vector 1 and this is the vector 2. Okay, vector 1 natin is 9.2. Tama? Alright, compute natin. Okay, so, medyo mahirap. So, vector 1. So, formula again of the sum or the magnitude of the vector, which is, let's say, R. Okay. So, resultant vector equals to the square root of A bar plus B bar. So, let's say, ito yung A bar, ito yung B bar. Okay? So, ang A bar natin, sorry. Okay, R bar, okay. So, square root of A bar, yung magnitude dito, so 9.2. Tama ba? Ito ay 9.2. Alright, so going back, may mga tumatawag. Bago tayo tumatawag. Okay, so A natin, going back, so A natin is 9.2 plus ang ating B is 14.11. Okay, so calculator. Wait lang guys, hanap akong calculator. Okay, sorry, meron pa pala tong ano, squared. So, 9.2 squared plus 11.4 squared. Okay? Parang distance formula talaga, ano. Okay, so ang value ng ating resultant equals 14.6492. Tingnan natin ko yung S, ang value ng S, ah. 6.4. Alright, so, ang sagot ko dito ay 14.6492. But the truth is, this is not correct. This is not correct. Okay? And, you might be wondering why. Sir, bakit mali? Well, looking at this representation here, this is not a perfect, this is not a right triangle. And if you're going to recall this one, okay, so this can only be applicable using Pythagorean theorem. So, what do we do? So, may na lang siguro. Or ituloy ko na lang ito. So, these are your two vectors. So, the technique here is to find first their x and y sum or combined x and y components. So, like I told you before, this vector has an x, has a y, and has an x and a y component. So, kukunin nyo muna x and y component yan. Tapos, binigay na dito, okay, tatabi ko muna ito. Tapos, binigay na dito, yung susunod na step. So, for vector A, so the x and y components, or the x component is negative 0.6, and the y component is negative 7.0. And for the B vector, okay, B vector for the x component is 11, and the y component is 3. Okay, so what I'm going to do is I'm going to combine the x and the y and the y, right? So let's say this is the x component. So the x component is 11 minus 6. So this is going to be 5. So the x component, the real x component is 5. On the y, the real y is negative 4. Okay, so negative 4. So, you're going to do this one. So, eto na yung x, 5, and this is your y, which is negative, oh, sorry. Hindi ko na pataas yan. So, pababa yan. And this is negative 4, and this is 5. So, ito na yung actual mo. Ito na yung gagamitan mo ng Pythagorean theorem na formula. Ito yung gagamitan mo ng formula na resultant is equals to a squared plus b squared, which is a bar. Alright? So, okay. So, ito yan. So, now that we know this, so, hindi na siya slanting tulad dito. So, siya ay straight na. Okay? So, pwede na siyang gamitan ng Pythagorean theorem. So, yun ang first step na gagawin nyo. So, the resultant here is gonna be 5 squared plus minus 4 squared. Okay? So, calculator. So, the answer is, the resultant is 6.4031. So, is it 6.4031? So, yes. So, tama na. Okay? So, that's how this is how you're going to compute for the resultant if you have a no. So, kapag Kapag, so, ganun ang technique na gagawin nyo kapag, sorry, kapag hindi Pythagorean yung ating vectors, kapag siya ay slanting na ganito, na hindi siya makakagawa ng right triangle, So, yun ang gagawin nyo. Kapag hindi, ulitin ko lang kapag hindi nakakagawa ng right triangle yung mga vectors nyo, kapag pinagdugsong-dugsong nyo, gagamitin nyo yung technique na ginawa ko kanina. So, paano nga ulit yun? For example, take this vector 1, vector A, di ba, punta siya dito. Always remember na meron niyang y component at x component. So, kukunin niyo yun. Kukunin niyo ang kanyang x component at ang kanyang y component. Yung isa naman vector is, pag ganito naman siya, kukunin niyo rin ang kanyang x component and y component. So, y component and then x component. So, gagawin nyo, ipagsasama nyo na itong x component ng isa, x component ng isa, y component ng isa, y component ng isa, para makakabuo kayo ng panibagong vector na ganyan lang ang itsura. So, pwede nyo lang gamitin ang Pythagorean theorem. Kasi siya ay right triangle na 90 degrees. So, kapag nagawa nyo na yan, guys, so pwede nyo lang gamitin ang formula na resultant ng isang vector ay equals to the sum of vector squared and the vector squared. So, ganun lang po. Okay? So, try natin na kapag right triangle na itong hiniyupak na ito. Okay? Let's say right triangle na siya. So, yan. Tanggalin ko muna itong sum. Then, another vector which is going like this. So type in sum. Okay? So, if you're going to do the tail end method, this is not a tail end. This is a tail end method. So again, end, then arrow, and then tail end. Kakagatin nitong isang vector, yung buntot ng isang vector. At then, lalapat natin ang resultant ng ganito. Okay? So, mapansin nyo, the resultant is 14.1. And we have 10. So, basic lang formula, no? So, obviously, the resultant for this one, applicable na agad dito ang yung formula kanina. So, resultant R is equivalent to 10 squared plus 10 squared. So, this is, resultant is 10 square root of 2, or this is equivalent to 14.21. So, check natin kung tama, yan, tama, 14.1. So, tama na. So, kapag right triangle ang binigay na problem, very straightforward. So, sobrang chicken lang. Kapag ang binigay sa inyo may yung mga slanting, gaya kanina, medyo matrabaho yan. Yun yung hanapin nyo yung x and y component ng bawat vector, and then ipagsasama-sama nyo. Saka nyo gagamitin ito. So, ganun lang. So, sir, applicable ba yun sa pag marami na yung vectors nyo? Yes. Ganun din ang technique na gagawin nyo kapag marami ng vectors. Okay, so that's the end of the vector lecture. I hope you learn a lot. By the way, may iwan na lang ito. Okay, so, kaya ba natin makuha ang direction using this one? Oh, well, basically, yes. So, for example, you have a vector like this, and you have another, you have a second vector that goes like this. Okay? So, using the tail end method, the resultant would be like this, right? And you can also learn the angle. Okay, so try natin. Try natin yan. So, mapapansin nyo, may nakikita kayong angle dito, ito. Yan na yung angle nitong vector na to. At ito, malalaman nyo rin ang angle niya. So, ito ay naka-angle 45 degrees. So, paano nakukuha yun, sir? Paano nakukuha ito? Okay, simple lang para makuha yan. So, titignan yung formula. So, we have tangent theta is equals to b over a. So, vector v over vector a. Alright, so vector, let's say this is vector v, this is vector a. So, that's gonna be tangent. Ano nga ito? 10, 10, 10. Okay? So, this is going to be tangent theta is equals to b. Alright, so this is b. This is 10 over 10. So, tangent, theta is equals to r tangent 10 over 10. Theta is 45 degrees. So, ang tanong, naka 45 degrees ba ang ating naka 45 degrees ang ating resultant. So, ganun lang ang technique, guys, para makuha yung resultant angle. So, did I cover everything? Oh, yes. So, huwag niyo napansin din masyado yan. Okay, so, para ma-review nyo, mas mabuti siguro basahin nyo itong book, itong lecture, naka-upload na rin ito naka-upload ito sa Moodle. So, this is how you're going to do the component vectors. So, I hope you learned a lot today. Goodbye.